Hi, welcome to Apache Spark. In this video, I'm going to cover Apache Spark, basically in big data analytics, or especially when we are managing the big data. And in that, Apache Spark is a very powerful cluster computing framework for large scale data processing. Apache Spark uses its own distributed runtime, integrates the Hadoop and benefit from in-memory caching. So if we are talking about the benefits, so Apache Spark basically ideal for iterative algorithm and interactive analysis. And this processes the complex data pipelines efficiently with the DAG, application platform interface and their modules in the Apache Spark. Basically, APIs in Scala, Java, Python, Ruby includes MLlib, machine learning libraries, GraphX, Spark streaming, Spark structure query language, and Apache Spark interactive shell for Scala and Python is there. Installation and uses, we may get this from their official website and by setting environment variables and run job using various APIs. Example, workflows demonstrate reading, transforming, aggregating, and saving data. And this is what the official logo, right? Come to next. Basically, when we are working with the Apache Spark, we have a RDD. We have a RDD. RDD, creation and operation, creating the RDDs from the collections, external sources, transformations, performs transformations and actions, utilize native Spark operations for optimization. Job execution, job starts with the action and are managed through a DAG of stages and tasks. Executors handle data processing, shuffling, results collection, and advanced features like persistence, cache RDD in memory with various levels of persistence, and serialization. The Java and Creo serialization for the data and function efficiency, basically a conversion, something like that. It is working through that shared variable broadcast variables for efficient data sharing, accumulators for counters and sums. And here is the breakdown for the key component mentioned, like Spark context, task scheduler backend, is executor backend, task. And if I talk about the particular Spark context, means the main entry point from the Spark functionality. It, it coordinates the job. Task scheduler is basically distribute tasks to worker node in a cluster. Scheduler backend is basically manages the interaction between the Spark cluster and the scheduler. Executor backend, the part of Spark responsible for executing tasks on the worker node. Task, basically Spark job are divided into smaller units called as tasks. Two types of a task are mentioned: shuffle map task and the result task, right? I will see with the help of a diagram, and this is few information I have taken from Wikipedia. You may go through. Basically, the original author is Matei Jaharia, and the developers is Apache Spark. First release is in 2014, around 11 years back. Stable release is 3.5.2, and this repository, like the Spark repository, written in Scala, operating system, Windows, Mac, Linux, and available in various languages. It may be Scala, Java, SQL, Python, R, C Sharp, and F Sharp. Types, data analytics, machine learning algorithms, license, and the website, right? Now, introduction to Spark job execution. How is Apache Spark is executing this job? Like a Spark job is divided into multiple tasks. Tasks are managed and executed across the distributed cluster using the different component. Spark component, as I mentioned earlier, Spark context, driver program that initiate the Spark job. Task scheduler responsible for rescheduling tasks on the available resources. Scheduler backend like interfaces with the cluster to manage the task execution. Executor backend like executes the task on worker node. Types of task in Spark: shuffle map task and result task. I will see all these through diagram. Then you will come to know what is that. And let me complete first theory part. And I'm going a bit fast because all the theory you may go through by yourself also. And I will explain diagram. You will come to know. You will connect all these dots, right? And job flow in Spark. The driver program in Spark context send the job to the task scheduler. Tasks are distributed and executed via executor backend. Tasks include both shuffling task, shuffle map task, and the result computation task result task. I would say that if you are aware about proper understanding with the map reduce, Hadoop, Yarn, and their working process, definitely you will catch this, all right? And how Spark run a job. So it's a very good diagram given in the very good book. Book name is Hadoop, the Definitive Guide, written by Tom White. It's a very fantastic book. You may refer this. A Spark program that run a job to a Spark context and run a job again, DAG scheduler, submit stages like a task scheduler, launch task to scheduler backend driver. Now launch task to executor backend, and from scheduler backend, then launch task to executor and task to shuffle map task and result task and executor. This is how Spark is running a job. Observe here, this is what I have mentioned, right? I was talking about. Go through this theory and diagram. You may come to know. Now DAG construction. First of all, what is the meaning of this DAG constructions? Who will tell about? Huh? So DAG construction in a Spark is basically to understand how a job broken in up into stages, and we need to look at the type of a task that can run in a stage, right? Task types of shuffle map task, purpose, data transformation, partitioning, output writing, process, RDD. I will come to RDD, right? Partitioning, write to new partition uses, and the execution context, all stages except the final one. Result task. Purpose, the process, final stage RDD partition, such as result in, you will count and some aggregation. Uses return results to driver, which may be a unit of, in the case of action, like a save as text file. And the job complexity, simple job like a single stage, no shuffling required, map only. Complex multiple stages, and there you require shuffle operation. An example overflow like histogram calculation with the help of a map function reduced by key function, map or swap or count by key stages. Shuffle map task reduced by key, result task count by key. And in big data analytics, DAG, direct acyclic graph, is a crucial concept used to represent data processing workflow. Here is the breakdown like directed means the edges connection between node means task have a direction indicating the order in which the task must be performed. Cyclic means no cyclic. In data structure there is a graph concept where you might have learned about this, so that you can connect it through that. The graph does not contain any cycle, meaning there is no way to start at one node and follow the directed edges back to the same node. Graph, it is a collection of a node and edges. In practical terms, DAG is used to model the dependencies between the different tasks and data processing pipeline. Each node represents a task, and each directed edges represent the dependency, showing that one task must be completed before another can be can begin, right? For example, Apache Spark DAG uses the to represent the sequence computation performed on the data, and this helps in the optimizing the execution plan and ensuring the efficient processing. And more complex job involves grouping operations and require one or more shuffle stages. For example, consider the following job for calculating the histogram of a words count. And I can say that this is the one problem, calculating of histogram of words count for the text file stored in the input path, one word per line. It is like while hist colon map int long data type, right? And we are fetching the attribute through this dot sc text file input path dot map word and word dot to lowercase, right? Reduce by key and map underscore dot swap. This is what I was talking about here. No? Example workflow. This is what the workflow, and probably it is written in Scala. So this is how it is programmed. Dot count by key. The first two transformative transformation map function and reduce by key function. You can see this map function and reduce by key function perform the words count. The third transformation is map function through this swap the key and the value pair format. Dictionary maintaining dictionary in the queue and value pair format. In the map, it is also doing the same thing, which returns the number of words with each count, that is the frequency distribution of words count. Spark DAG is scheduler turns this job into two stages, like reduce by key operation versus shuffle stage, and the resulting tag is met. So what is the RDD? I was talking about resilient distributed data sets are the fundamental data structure in the Spark, providing the fault tolerance and the parallel processing capabilities. Stages means what? Spark job are divided into stages based on the shuffle boundaries. These stages consist of tasks that can be executed in parallel. Transformation and actions. Transformation means like map to pair, reduce by key, create a new resilient distributed data sets from the existing ones. And while action like count by key trigger the execution of the transformation to produce the result. And the one diagram I have listed here, that is the showing the visualize how Spark process data in the distributed manner, breaking down the complex computation into the manageable stages and the task. Observe here, very important diagram. Right, you will able to see this. First stage is shuffle and map task. Second stage is the result, right? So, so I can say that let me pause the. So here I'm talking about the two stages, shuffle map task and the result task. Here RDD string text file, RDD string int map particular function, RDD string integer that reduced by key, and in the result task RDD string int reduced by key, RDD int string map and RDD map int and long count by key. RDD dependencies, like this arrow is showing the resilient distributed data set dependencies. Right? So the stages and RDDs in Spark job for calculating the histogram word count. If you are drawing this diagram with this particular, you can say, program and explanation, you may be able to understand the whole concept related to calculating a histogram of words, right? And through Cloudera and the VirtualBox, you may run this and we'll get the output to that. Understanding the Spark job diagram. The diagram basically is explaining the stages of resilient distributed data set involved in the Spark job for the calculating histogram of word counts. This process broken down into two main stages, right? So one is a shuffle map task. Here text file was there, map to pair and reduce by key. And what is the purpose of this? This operation reads the input text file and creates an RDD of a string, and where each string represents a line in the file. Map to pair, basically this transformation converted the each line into key value pair, and that to string and int. You can say this is key, this is pair, and where the key is the word and the value is one. Reduce by key function basically aggregate the values by key as a word, summing up the count of the each word to produce the RDT in the form of key value pairs. And when it comes to stage two, like a result task, they are also map to pair, and reduce by key and the count by key. And the same thing, like the transformation of remaps the string into pairs to string into string, right? A conversion between key value and their types, effectively swapping the words and its count. Reduce by key. This operation further reduces the data by key, although in this context it might be redundant since the keys are now count and count by key. The purpose is to count the number of the occurrence of the each unique count resulting the histogram word count, right? And when an RDD is persisted from the previous job within the Spark context, the DAG scheduler avoids recomputing it or its derived RDD, saving computation effort. And the DAG scheduler role is to split the stages into tasks for the task scheduler. For example, the in the first stage, the shuffle map task is executed for each partition of the input file. The parallelism level for reduced by key operation can explicitly set off or determined by the number of partition in the parent RDD. The tasks are assigned placement preference to optimize data locality. For instance, task processing partitioning of an input RDD stored on the SDFS will prefer the data node hosting the partition block node local, and while task processing partitions of an RDD cached in memory will prefer the executor storing the RDD partition process local. Once the DAG scheduler construct the complete DAG of stages, it submits each stages task to the task scheduler. Child stages are only submitted after their parent stages completely successful. Now, what is the task scheduler? Task assignment and task executor mapping. The task scheduler assigns tasks to executor based on their availability and the placement of preference. Executor mapping means constructor mapping of a task to executors, considering the placement preference to optimize the data locality. Task assignment process basically free course and the core allocation. Tasks are assigned to executor with free cores. The scheduler continue assigning tasks as the executors complete their current task and the core allocation. By default, each task allocated one core, and but this can be adjusted using the spark.task.cpus, right? Placement preference, process local task, node local task, rat local task, non-local, and speculative task. So task for the process local task are first assigned to executors and have the required data in memory. No, when I will talk about the node local task, next task is to assign to executor on the same node as a data. And rag node local executors are available, then the tasks are assigned to executors on the same rack. Like non-local and speculative tasks, finally tasks are assigned to any available executor, and speculative tasks are launched if enabled. That was the task scheduler. Now I'm talking about the task execution. Task execution means scheduler backend and executor backend, right? So one part is scheduling, another part is to execution. So for scheduler backend, these are all things we have seen in the previous diagram, right? Assigned tasks are launched through the scheduler backend and which sends a remote launch task message to executor backend, and executor backend receive the message and run the task. The executor operations dependency management, the executor ensure that Java archive file dependency are up to date using the local cache to avoid the redundant downloads. A task serialization. The purpose of this to in the code and the including user function is to deserialize from the serialized bytes received. Task execution. The task is to execute it within the same JVM as the executor, eliminating process overhead, right? Task completion and the status update. And if I will talk about the result reporting, the task return result to the driver, which are serialized and sent back to status update message. Shuffle map task return the information for the text next stage, retrieve output partition. Result task return the results from the partition, which is driver assemble into the final result, handling task failures, so resubmission and speculative execution. If the task fail, the task scheduler resubmit the it on the another executor. Speculative execution, speculative task launches to slow running task if needed, right? Now, very important topic, executor and cluster manager in Apache Spark, that we will discuss in the next video, right? So I'm stopping here, and I hope you are enjoying this all. Learn by this. If you have any problem, let me know, right? Thank you so much.